Or you can download Microsoft, and essentially you just open the top of software.
Stand up, everyone. So this afternoon we are still continuing on our quest to understand the 12 causes of disease. We just completed the laws of health. And let's see if we could remember what we've done before the laws of health. Laws of health took like 4 weeks. So we did the laws of health, which was 4 weeks ago. We have been working on it. And before that, what did we do? Let's see if we can recap real quick. First one that we did was what?
Acidosis.
Acidosis. And what's the second one? Nutrition or nutritional deficiencies. And then after that, we did the 8 laws of health. So today we're starting the 8 channels of elimination. So this is going to be another 8 weeks.
No,
to finish
we're
up.
try to cut it short.
So somehow we can condense some of these in a week, 2 in 1 week. Yes, so when I looked at the 8 channels of elimination, I mean, we might not have all 8 of them up there, but you know, I wondered, where do I start? And I felt like it was fitting to start with the cell membrane. That's where I felt like it was most fitting to start. And the reason why I felt that it was better to start with the cell membrane was because the cell membrane is fundamental for everything. We are all of us, our entire existence is made up of cell. Our whole body is cell, our physical structure is cell. Life exists at the cellular level. That's where life exists. We don't see the cells, but that's what make us up. So everything else that comes after the cell is made up of cells. So I felt like that was the most fitting place to start. And we are looking at the cell membrane today. Okay. So these are the 8 channels of elimination. The cell membrane. And the cell membrane is somewhat always compared to the skin of our body. Then inside we have the blood and all the lymph, the colon. We did a colon already. We already looked at the colon. So the colon is going to be struck out of this series of presentation. We have to fall back on the presentation that was done prior on the colon, the liver, kidneys, and the lungs. Okay? Now, I just wanted to show you this to lay a foundation as to the levels of organ. It just happened that the cell membrane fall within this range, and we're not going past the tissues. When we look at the other channels of elimination, we can tie that in with our tissues and our organs and the organ systems. So today we're going to stop at the cell. Okay? Okay, so a cell. So a cell is the most basic unit of structure and function. So all of us, everybody, all living things are made up of cells. And all cells come from pre-existing cells. Okay? So this is a cell. Okay, so we have a cell right here, and this could be a whole organism as we know it. These are the parts that you will see under a regular microscope if you look at the cell under the microscope. Okay, so you might be able to see the cell membrane in the nucleus, and you could assume that this is where the cytoplasm is. Okay, so, and this is a typical animal cell. And on this cell, where do we have our cell membrane? It's where is it found? Can you see it? It says cell, and the cell membrane is also called the plasma membrane as well. Where is it found?
The outer.
So it's the outer lining. So this would be the plasma membrane, and they interchange plasma membrane with cell membrane. So you will hear plasma or cell membrane. Okay, so this is a typical animal cell, and this is a typical plant cell. And there's a difference, but every cell has a cell membrane, whether it's a bacteria, any kind of cell, or a single cell organism, they all have a membrane. So the cell membrane is fundamental to life because it separates the inside environment of life from the external environment, which is not necessarily alive. Okay, so the cell membrane of a plant cell is somewhat different. It is different because it has an extra layer surrounding it, which is called a cell wall. So inside, or after you pass the cell wall, it is the cell membrane. And this is what kind of keeps the plant upright. A plant is usually or should be erected and upright at all times. So the cell wall kind of keep, all the cells inside of the plant has to be turgid and filled with water for it to stay upright. If it doesn't have enough liquid in it, what happens? It wilts. It's not gonna die, but you must have had plants in your house and you didn't water them and they start looking like that, and a few hours after they start looking alive again. So the membrane along with the liquid inside of the walls, along with the liquid inside of the plant cell, keeps it upright. Okay, so the wall is very important in a plant cell. Now we're looking at the plasma membrane. And this is some science that no one or most people take the time out. Really, let's look at the cell membrane. What is that? If you just see from what we just did, we just never ever think about studying the cell membrane. We're not even looking at cell. But, in essence, this is what the cell membrane looks like. Now, it is the layer that surrounds the plant and animal cell or any cell that exists. It is that layer that surrounds or protect the cell. So the cell membrane serves the purpose in the plant cell as protection and animal cell as protection. Plant cell has an extra wall that protects its cell membrane. Just the animal cell just have a cell membrane. Okay, so this is what it looks like blown up many times in order for us to see. As if you think about a cell, we cannot see cells with our naked eyes. So this is blown up in many, many, many dimensions for us to really be able to actually view what it looks like. Okay? Now the cell membrane or the plasma membrane is the gateway to the cell. Now, what is a gate? Why do we have gates on anywhere if we have gates?
To enter.
We needed to enter, but what's the purpose of putting up a gate or a fence or a wall? To keep stuff out, right? We don't want everything to enter, right? So the cell membrane is the gateway to the cell, and that's one analogy or way we could look at it. It's the gateway. So what would that mean if it's the gateway? It mean that it's open, everything could go in?
Selective.
It is selective. It is trying to decide. It decides what goes in because it's a gate. It's not everything that passed by should enter. Okay? So something is missing from the sentence. But our goal for this evening presentation is to really understand the correlation with the correlation of the cell membrane with disease. That is primarily, and in order to understand that, we must look at the structure of the cell membrane and understand how it works. Okay, so it's very important that we understand how it works. It is, in looking over all the things that I've looked at with cell membrane, I recognize that it is like the fundamental. This is where it happens. This is where we become deficient in any disease. If our cell membranes are not working the way they should, then we become deficient. If we're taking in food, if they're clogged, it's so many ways the cell membrane is, if it's not functioning the way it's supposed to function, all the disease that we presently experience occur as a result of malfunctioning of the cell membrane. Okay, now this is a real cell membrane, a live version. It's not like, we could see that cross section, that's the cell membrane. Now, this is single cell organism, one organism that carries out all the life processes. And this one organism, if it had no cell membrane, it would be just mush. So it would not be able to move because the cell membrane allows them to propel along wherever they live. Some of these live in our bodies as well. Okay, it's the surrounding cell membrane in this organism that gives it its ability to move around. Okay, so it gives flexibility. This is a single cell organism. Okay, now the cell membrane helps, it maintains homeostasis. Now homeostasis is maintaining balance within our body. Now what balance do we need to maintain in our body? Okay, so we need to maintain a constant temperature. That's a big one. So what happens when it's very hot? What do? We start sweating, right? Now what is the purpose of the sweat?
To release toxins.
It's releasing toxin, yes, but what? The primary purpose is to cool the body down. So our bodies are so wonderfully made that if our bodies start overheating, then we start sweating, and the sweat is to cool the body down. That's an example of homeostasis, maintaining balance. If we get a bacterial infection inside of our body, what happens to our body? What's the purpose of the fever? What is it doing in the temperature? It's killing, it's burning. It's like a fire that's lit inside of you to burn the microbes that's inside of you. That's the purpose of the fever, right? So when you get very cold and you shiver, what is that creating? It's heat. It's shivering. The purpose is to heat the body
It's
up.
closing all the little pores.
Right. The pores are closed and you're shivering, so you produce heat. Exactly. So all of those are examples of maintaining homeostasis. Okay, so internal balance must be constant in order for you to stay alive. Okay, so the cell membrane plays a very, very important role in maintaining homeostasis. So just like your body gets hot, you start sweating. If the cells doesn't allow the liquid to go out, what is going to happen to us? We're going to have extra heat. We're going to pass out. We're going to short out, just like when the circuit short out in the house and the fire start. It's the same thing that's going to happen within our body if the cells or the pores or the membrane of the cell doesn't open up and allow liquid to leave the body to cool the surface down. Now, another name for homeostasis or maintaining balance is equilibrium. Maintaining equilibrium. So it means equal or a balance, just the same. Now, the plasma membrane is involved in controlling what enters and what leaves our body. So that is how it helps to maintain homeostasis or maintain a constant internal environment regardless of what is happening on the outside. Okay? Now, the function of the plasma membrane. It's a protective barrier. That's one function. It regulates transport in and out of the cell, and that in itself is saying that it's selectively permeable. It allows cell recognition, and it provides an anchoring site for filaments of cytoskeleton. Okay, so it allows, it protects. That's a big thing that the plasma membrane does. It protects the body. Okay, it regulates what goes in and out, and it allows cell recognition. So it allows cell recognition, which means that there are some cells like bacteria that could enter the cell membrane. And there are other things that would enter the cell membrane, but the cell membrane has to decide which one it should reject or which one it will allow to enter for the benefit of maintenance. And we're going to see where the anchoring of filament for cytoskeleton is when we look at the diagram. Now, it provides a binding site for enzymes, which is very important for our body to function properly. It also comes right back here on the plasma membrane. In order for the cell membrane to function properly, there has to be enzymes. And what are enzymes? What are they made up of? Anybody know? Remember? Enzymes are made up of protein. Okay? So they are, in essence, protein, and they function to speed up reaction. That's what enzyme does. Okay, and we have enzymes in our mouth, we have enzymes in our brain cell, we have enzymes all over our body. And if enzymes are not what they should be, then our body will not function properly. So we have enzymes that aids in digestion, and that is the one that is very popular that we will remember all the time, that it aids digestion. But once our enzymes are not, so enzymes are made of protein amino acid change, then there are changes that occur within our body. So enzymes are absolutely necessary for the cell membrane to function optimally. Interlocking surface binds cell together. So the surface or the cell membrane itself, the interlocking, and when we look at the membrane in a little bit more detail, we'll see where it binds cell together. So the cell itself is bounded by the cell membrane. It's like the gate, it's like the walls in the house, or the gates that surround, or the fence that surround the house. So that's what the cell membrane is. And the cell membrane contains cytoplasm, which is the fluid which all the other organelles in the cell is submerged in. Okay? So this is a structure of the cell membrane, and we could look at some of the things that we just talked about. Now, we have protein channels as part of the cell membrane. We have protein molecules. And this is the outside and the inside of the cell membrane. It's made up of, and we're going to look at what it's made up of, lipid and phosphate. And we will look at that in a little bit more detail. And then we have the carbohydrate chain and the protein molecules. And this is the simplified version. Okay, so these carbohydrate chain, we could look at them as glucose, but they all serve their different function in the cell membrane. So this kind of gives us a little bit more detail of the membrane itself. We have the phospholipid bilipid layer, which is right along here. And these layers, they all have their different characteristics. We have cholesterol, and the cholesterol helps to keep the cell together, and it also, it helps to keep the membrane together. So fat is very important in keeping the cell membrane together. We have the protein, and these are pumps that allow things that are too big to enter and to leave the cell. So there are some things like, water molecules will go through to a certain extent, but water moves within the cell by osmosis, and it also needs a channel for it to go through freely. Some protein molecules are not able to go through the cell membrane. Okay, so we will have things like glucose and like carbon dioxide and oxygen. Those will go through freely because they don't have a charge on them. Water does have charge, so it is affected. Okay, so these are some of the components. So we have a protein, a carbohydrate, a phospholipid, and the cholesterols. Okay, so here we have the cytoskeleton, which anchors the protein that is used to pump or channel minerals into the cell and out of the cell, depending on the concentration that is the concentration gradient. And this is another diagram. This is the phospholipid. Now, the phospholipid has a polar and non-polar area. Okay, so the polar head, which is up here, and the non-polar, which is here. Okay? And another feature of the cell membrane is that it's fluid mosaic model. It has a fluid mosaic model. So it is fluid, meaning that it is not stable, meaning it's always going to be moved. Individual phospholipids and protein can move side to side, and it's not in a particular shape. That's why the reason why our plant cell stays like a box in most cases, if you remember, it's because of the cell wall. But a plant cell doesn't have a particular shape. The shape changes, and that's because of the fluidity, and it says fluid mosaic. So it moves side to side. So because of the cytoplasm in it, if the cell is going to move, it's going to change shape. Okay, because of the pattern, it's mosaic because of the pattern produced by the scattered protein molecules when the membrane is viewed from above. And we have carbohydrate on the top. These are protein molecules that is used to pump things into the cell. And as I said, things like glucose, the molecules of glucose don't go through the cell membrane freely. Glucose will not go through freely. And some of the amino acids are too big to go through, so they will not just enter the cell membrane and fall through. So the glucose will have to be pumped, and in cases, water molecules will need to be pumped in when osmosis occurs. So the cell membrane, and we talk about polar head, which says here the polar head are hydrophilic, meaning it loves water, and this is the top of the cell membrane, and at the base, so these round parts here that we're seeing, they are hydrophilic, and the inner part, which is the tail, right along here, the tail is hydrophobic, meaning it is afraid of water, okay, or water faring, and they work nicely together, and that's what makes the membrane selectively, okay. That's what creates the selectivity of the membrane. Okay, and these are 3 lipid soluble molecules, as is stated. Now, these are the 3 things that would just go through the cell membrane. Okay, and if you do deeper studies, as I said, water have a charge on it, so it's not in all cases where water will just go through. And this I could say as a fact, because when I do live blood analysis and look at the cell membrane or look at the cells, you could see water molecules attaching to the outside of the cell membrane. So therefore, it tells me that sometimes there are blockers that are preventing, even though you're drinking water, the water is not entering the cells, so you're not getting the benefit of it. And it is quite true for other things like insulin. When insulin is produced, if the cell membrane is clogged, will the insulin get into the cell as it should? No. So when we have a lot of fat particles inside of our cell, that clogs the cell membrane and prevent insulin and other hormones from entering the cell. And that is why when we do a detox, a lot of people associate a detox with cleaning their bowels. It's not the bowels that needs to be cleaned because life exists at the cellular level. We must clean the cells. You don't feel lethargic and sleepy because your cell is active and functioning optimally. It's because our cells are not functioning the way they should because your energy comes from the cell. All the food that you just eat, when you take that food in, it must be digested. It needs energy to digest it. Where does the energy come from? Energy has to come from where? It has to come from the cell. It's manufactured inside of the cell. The nutrients from the food you eat need to go where? Into the cell. So if the nutrients can't get in the cell, where are you going to get the energy from? So the energy is non-existent. So when you start feeling that way, it means that the cells need to be clean. The cell membrane need to be clean. And if we clean the cell membrane, we are going to see how different our body function. Okay? And as long as we're eating the right thing, but cleaning the cell membrane involves a process. So that will put us in the direction that we need to go. Okay? So the cell membrane is made of two layers. A phospholipid called the bilipid layer. Okay, so it's two primary layers there for the cell membrane. And it is, and this is also a part of the reason why the cell membrane is selectively permeable. It means that things just can't just run through the cell membrane like that. Not everything is going to get through. It will allow what it wants in the cell membrane or to pass through. Okay, so it is a double layer, and the layer is made up of fat and phosphate, and those are the two things. And we kind of just look at this. So the hydrophobic molecules pass easily. Okay, hydrophilic do not. Okay, so the cell membrane is in essence, so we look at this area, water, extracellular fluid, and this area is the same layer. Okay, now inside here it's hydrophobic, hydrophilic. Okay, so if we look at it in a little bit more details, here we have the polar heads and we have the non-polar heads here. This is the part of the cell membrane doesn't like water. Solubility. Materials that are soluble in liquid can pass through the cell membrane easily. Okay, so some things that are soluble, and what are some examples? Can fat pass through easily? Can we get some starch and just it pass through? Why can't a starch molecule pass through? It's what? It's too big to pass through.
So you're gonna need transporter.
So it needs transporter in order to go in. Okay, so we have example of molecules that are small enough to go through. So it says oxygen, carbon dioxide, and water will go through easily. Does that mean sugar will go through easily? Sugar, carbohydrates, or starch has to break down to what?
Glucose.
And glucose, does glucose go through readily? And it will still not go through. It needs a facilitator in order for it to go through the cell membrane readily. Because it's not among these, so it's not going to go in as easily as water, carbon dioxide, and oxygen. Okay, so ions and hydrophilic molecules, so larger than water and large molecules such as protein do not move through the membrane on their own. So our amino acid cannot, and well, you might have some of them that will go through readily, but not all of them can go through. Okay, so it's important, types of transport. And I just want to demonstrate the different types of, just demonstrate how transport occur in the cell. And I have a setup here just for us to look at the process of how materials move into the cell and out of the cell. We might not do the out part because then we'd have to test if glucose leaves the cell, but we could see clearly that it can enter the cell. So we have different types of transport. So we have simple diffusion. And simple diffusion will occur with things like water and carbon dioxide and oxygen. So that simple diffusion, okay, require no energy. Molecules move from area of high concentration to area of low concentration. And if we look at this, what do you notice when diffusion or the molecules start moving? What is one observation? They spread out and what is one word we could say, use as a description of that? Are they, they're scattered, but a word that we used earlier. They line up in order, but what is another word that we used earlier? Are they on equal distance apart? So they are at what we call equilibrium. Okay? So diffusion is a passive process, which means no energy is used in the process. So molecules just move about. If we spray some perfume in right this corner of the room, the perfume has a high concentration right here when it's just sprayed. But after the molecules start bombarding against each other, and they're going to spread equally throughout the room, and to a certain extent, when it gets equally here, it probably will go upstairs and wherever, and the molecules will be all at different points until you don't smell it anymore. Okay, so that's diffusion. Okay, so what I want to do, I just didn't want to do this by myself. I need help though, I need a volunteer to come and help me. So this membrane functions somewhat like the cell membrane. It is, and what is one description of the cell membrane? What did we say the cell membrane was? It protects, and this is mimicking the cells in your body. So one function of the cell membrane is that it protects. What is the characteristics of the cell membrane besides protection? It is what? It is selectively permeable. It is flexible. So the cell membrane is selectively permeable. This material is also selectively permeable. Okay, so we're going to, I need help. Can somebody help me, please? So we're going to tie one end on this, and we're going to create a cell. You're supposed to tie this for me. So we're going to create a cell, which would represent the cell. Make it tight, real tight. No, that's not tight enough. So what we're going to put in this, we're going to put starch molecules. We're going to put liquid starch. So this is liquid starch. So the idea here is to demonstrate how things are, how the cell membrane function, how selectively permeable it is. Okay, so this is liquid starch. Alright, and we're gonna tie this again, so this is gonna represent our cell. So I put starch in there and it's liquid starch, alright. So then we're gonna put this in some water with some starch indicator solution. So this is what it looks like. We're gonna see whether or not anything enters this cell. I'm gonna drop this in some water. Okay, and this is iodine. This is a starch indicator. So if anything has starch in it, this is gonna turn black. Whether when you put it on anything that has starch. So I'm gonna put some of that in there. This is what it looks like. So there's no starch in this, or else it will turn black, alright? So we're gonna drop the cell in this, and then we're gonna wait for a little bit to see what happens. Okay, what did I say would happen if starch is, if it enters, touches anything with starch in it?
It's gone black.
It turns black.
Take over.
This don't have no starch in this, okay. Okay, so wherever it touches, as long as starch is there, it's going to turn black. So this is diffusion. So we said it's a passive process, and it just happened randomly. It's not like you need any force, any kind of energy in order for it to occur. Okay, diffusion of liquid. So as you notice, when I put the iodine in this, you notice how it spreads throughout, even without shaking it up. And that's another example of diffusion that occurred inside of here when the iodine was added. And it's the same thing that is happening here. And this is kind of similar to how the cell membrane function within your body, how things diffuse throughout your body. So this is the molecules as it was, and then the molecules, they randomly start bombarding until they spread equally out, and it's the same thing that happened. So this occurs in a lot of process. This process occurs in a lot of things we do every single day. It's just that we don't think about it when we say, or when we put some sugar, or we put some herbs in hot water, and it starts pulling the components from the herbs. It's the same principle that is happening. This process is called diffusion. Okay, and this is also diffusion through a membrane, which we are demonstrating there. This is the membrane, and we have high concentration here and low concentration there. Remember, the concentration must be high at one point in order for it to diffuse throughout, as long as it's going to be diffusion or simple diffusion. When the diffusion requires energy, then it is going against a concentration gradient. Now this is going down. It's just like you're going down a hill. It's easier to roll down the hill than to come up the hill. So that's really a similar principle. Now osmosis. Osmosis is a special type of diffusion that requires, it's only the difference is that it involves water. So osmosis is a special type of diffusion that you give to water movement. So diffusion of water across a membrane, and it's from high concentration to low concentration. So that is the same principle, but this one is specially given to water, osmosis. Okay? So this is diffusion of water molecules across a membrane. Okay? Now, if we notice here, can all the molecules go across the cell membrane?
No.
Okay, no. Why? What was one reason why you think all these molecules are not going across the cell membrane?
There are many reasons. One, the green one are very bigger. You're gonna need transporter to take them from outside into inside. The transporter is called the pump.
Potentially. Right. So, and the water, if you notice, the concentration is high there, it moves over here, it's high over here, it moves back and forth. So that's just how it works here. And this is how it is moving. Okay. So we have the aquaporins, and this is where the water channels come in. So water channels, protein pores used during osmosis, okay? And these are water molecules that are going through the cell membrane. And sometimes a lot of us, this is what might have to happen. It requires a lot of energy for just the water that we drink to go through, when in essence, it should be able to pass through. But this might occur because our cell membrane are so clogged, the water molecules can't go freely across. So it's a special channel that has to carry the cell membrane across. Now, cell in isotonic solution. Now, what does that mean? Okay, if it's isotonic, look at the concentration. We have 10% sodium chloride, 9% water. Where is this? We have 10 and 90 here. What, is there going to be any movement? No, there's not going to be any movement because you have equal amount on both sides. Okay? So there is equal going in and out, so it is stable. This is a stable environment. So it's at equilibrium. Hypotonic. And look at the numbers. So remember, diffusion is moving from high concentration to low concentration. Where is this movement going to occur? From where to where? Huh?
Which movement?
So there's going to be some movement of liquid from, so we are trying to figure if it's a hypotonic solution. So inside we have 20% sodium chloride and 80% water. Outside we have 10% sodium chloride and 90% water. Where would we have greater concentration?
Inside the cell.
Inside the cell. So where is the liquid going to be moving?
From the less concentrate to the high concentrate.
Okay, so it's going to be moving.
Because the cell is going to create a pressure on the cell membrane.
Okay, so here we have a hypertonic. Where is this? Where's the solution going to be moving? Where is the concentration greatest? So it's going to move where?
From the cell to outside.
Okay, from inside to outside. So these are the three solutions. Here we have hypotonic, where the liquid is going into the cell. Now, hypo meaning concentration will be greater on the outside and on the inside. And this is what happens literally within our body. Okay, external is hypertonic. This is like when we eat very concentrated things like salt and sugar, and then we get thirsty because our cells dry out. So they start looking like this, so therefore we become thirsty. Okay, and then external is iso, when we have equal amount, and this is when you feel like you're bouncing off the wall and the cells are functioning. Because when the cells start looking like this, now when the cells start looking like this, you start feeling lethargic. Now when we have equal amount entering and leaving the cell of solution of whatever nature, then our cells are going to be at equilibrium, right? So this is equilibrium. So when we go to the hospital and they give us a drip, what solution do they use? Huh? And what is the concentration and that in relation to our body? So the concentration of the saline solution in relation to the solution within our body, it is going to be equal. So we could say it is isotonic. Okay? So the isotonic solution, what would happen to the cells? If you put that directly in your veins, yeah. Okay. Okay, so the cell would expand and eventually the cell would pop. So that's what would happen. Okay, so the solution is already, it's entering the cell. So animals that live in a pond, they live in a pond. These animals, how do you think they survive?
They live on what?
They live in a pond, fresh water.
Oh, in the fresh water.
Yeah.
Okay.
What is the adaptation, or what adaptation do they
And
have?
we're talking about fish, right?
Oh, it could be fish, yeah. Any kind of organism that lives in a pond, they have cells. So I'm talking about this kind of. Okay, so this would be the solution that would be for the organism. So water is constantly entering and none is leaving. So the water is going into the cell, and eventually, if you have cells in your body and you live in fresh water, then this is what is supposed to happen.
Wow.
Your,
Hypo?
your cells start popping.
No, restart. You see this animal living in water have hypo? Tonic?
The water itself is somewhat hypotonic. So I'm saying, if we live in that water,
Or we?
but they have cells, so we're looking at life from a cellular perspective.
Mm-hmm.
Why don't these organisms pop?
Cause that's their environment.
They can have a membrane that is not permeable for the water to just go through and out, or they can have isotonic when the in and out are very balanced. So one pop, it won't squeeze either. So to keep, you need a balance. Okay, the outside and inside should be balanced, or you have a membrane that water can penetrate. You know.
But they do, huh? Right, they have a special pump that allows them to push the water back out when it comes in. And just like the fish that lives in the ocean, they have a special adaptation so that they don't dry out. But it's a
So that's
principle.
isotonic solution.
Yes, so the salt water will be isotonic. No, not isotonic, hypertonic. Yeah, so isotonic is equal. Hypo is too much of the fresh water going into the cell. It's not the same as the liquid in our body. So the salinity is different.
But I'm talking about the fish you're talking about. The fish is there, right?
Mhm.
Did the fish get a lot of water inside herself?
Which one?
Maybe I'm not understanding your question.
I'm just saying which one. It says, so it could be fresh water.
No, we're referring to the fish in the water like you were talking about.
In the ocean?
Mhm.
Yeah, so that would be, they live in a hypertonic solution, but is able to push out excess salt water that comes in, so they don't dry out.
But because they are made up to live in the water, so their cells are made up to adapt to
It's an adaptation.
the environment.
So they have a special pump either way, whether they live in salt water
Yeah,
or they live in fresh water. That pushes, whether the salt water, the water, they have to get rid of it, so it doesn't dry their cells out. And it's all, an adaptation that organisms have. Okay? Okay. Okay, so, and these are like red blood cells that we would have in this, so what solution would this one be? Somebody could say, what solution? Is it hyper or hypo or isotonic?
That's isotonic.
And this one,
I
That's okay.
and this one.
the reverse thing.
Okay, so this I had to count. Very good. Okay, and these are the same. Let's look back on our cell that we set aside and see what happens here. So this is what happens to our cell. So it's very similar to how your cell membrane should work. So this is the starch solution inside of the cell membrane, and as long as I said before, it comes in contact with starch, then it's gonna change. The color should be blue-black. But it needs to be in there for a little while longer, and then you will see how the color change. So that's how
Now,
diffusion
question here.
should occur. Now, see, this is the starch on the expression bottle.
Now, in a practice, when we have the cell membrane, have let's see, the cell membrane have bad fat or mucus built around the cell. It does not allow things to go in, things to come out. Then what happened to our energy level? Even though you're eating good food, you're in all of this, and then you're having this mucus or bad fat built around the cell.
So the cell membrane will be clogged. So we won't have anything, and it's not that nothing will go in. There's always
No, nothing. Like,
So
you're going to be
you will-
resistant to some of the stuff.
so some things will go in, and for those
It's
things
two of them.
that need a pump to pass through, you know, they will enter the cell still. You're always gonna have a little bit of something going in the cell, but if there's mucus clogging the cell, if you have mucus clogging the cell, then your energy level is definitely gonna go down, because that in itself require energy for things to pass over the cell membrane. And the energy is not, the cell membrane is not, it's clogged, so things, first thing, insulin cannot get in.
So you have insulin resistance.
Exactly.
Because of what? Because of the acidosis creating mucus buildup around the cell and it clogged up the insulin receptor. So the insulin receptor is clogged up with mucus, you can't get insulin in. That's the reason why you do cleanse with the herb that's gonna cleanse the cell membrane. So if you don't clean the cell membrane, you can take all the insulin you want, you're in trouble. That's the
That is
reason
why they constantly increase the amount of insulin
Insulin.
that
So when you put a patient like that on natural treatment, you gotta go slowly. Cleansing the cell, cells getting better, you can take more insulin in, and then the person go back to the doctor regularly to be diminishing the insulin intake until you bring, because at the same time you need to know that the cell membrane is broken. It needs to be healed. It doesn't heal like 50% fat, 50% protein that need to be healed to be repaired. So that way you know exactly what's going on. But if you just tell the patient, oh, get all medication, just take the herb, you're gonna kill someone, you go straight to jail. Because you gotta know that you need to repair the cell membrane, cleansing the cell membrane, and balancing things slowly until the cell recover the normal functionality. Then you're gonna be free. At the same time, you're healing the pancreas. The man who's gonna produce the insulin. They also help the liver now, because liver gonna manage what? The fat management. So that's why you're gonna need to understand how all these 8 channels all work together for the cell to work right. Are we getting the picture right now?
and first
So-
of all, the cell must work right before all the other organs could work
Right.
properly, right?
So it's extremely important this section we're doing here, the 8 channel of elimination. If you understand how the A channel works, you can know all the herb you won't succeed. Because many cases you're gonna need to use a little bit of common sense to see why this is going on. Why does it have so much edema? The lymphatic is clogged up. What happened to the lymphatic system? What happened to the cell membrane? So this is gonna help you to know what can I do, what the person will take, what can increase this. Okay. So that's how you get it done. You know, so I really encourage everyone to pay attention to this because they mean everything, especially for people who want to practice natural stuff.
And that is why when a lot of people come and say, what can I take for my headache? Or what can I take? It's going to be as simple as, just very simple. As a naturopathic person or as a medical mission or whatever you want to call yourself, it's always very important not to just say go home and take this, because you don't want to give natural remedies a bad name. Because most people are clogged up, they are clogged up every way that you could think. And because of that, their body will, whatever herbs you're going to give them can't work. It will not work. So you must clean, as Pastor Coco just said, we have to clean first. That's the first step in any program that you're doing. We do a cleaning. You clean from top to bottom. You gotta wash everything off. Then after that, you could add your herbal remedies. So all they need for the first 5 days of any program is just cleaning. And then after cleaning, then you could have add any herbs or whatever you are going to give the client for their specific condition.
Remember this herbal doctor that I met back home, he said you cannot put on clean clothes on a dirty body.
Yes, you can.
The reason why he said that is that unless you clean the system, you can't put good stuff in. The body is still gonna be deficient.
Yeah, and that's very valid. When I understand the context in which it's used, you don't put clean clothes on dirty body. I mean, that's what, that's the microwave method of healing, and it doesn't, in most cases, it doesn't work. And that's why herbs get a bad rap. It gets a bad rap because it doesn't work when the cells are clogged up. Okay? So we have the 3 ways things pass across those 3 different types of solution that goes. Now, okay, so when we are dehydrated, this is what our cells literally look like. When the conditions are right within our body, this is what it looks like. Now, what would our cells look like when we have a swollen ankle? Which one of these? Yeah. So what solution would represent that?
No, say the question again.
We're looking at these and we're trying to associate them with a swollen ankle or
Edema.
yes, or edema, any of those conditions. Okay, so it will be hypotonic. So hyper is ideal. Hyper is the ideal. Okay. So hypo is when expand. So here you notice it's just going in. It's pouring in. But here would have equal going in and equal leaving. And here it's just leaving. Right.
Question.
Yes.
What about instead of the liquid being stored inside the cell, it got more stuck in the lymphatic fluid, and you are not sweating, so everybody just stay there.
So it's like a swole condition.
Yeah.
So it's
Big edema, like right there,
mhm,
because you have interstitial fluid that should be washed away like It's our bathroom, our sewer system. So when the sewer system gets clogged up, how do we associate that with the cell swelling? Like somebody have a big feet, two big feet right there. So we see cell swelling, but also the lymphatic fluid, the lymphatic system is what? Congested.
So yes, so we have both of them, we have the
Both of them
congestion.
at the same time.
Exactly.
So now you're gonna cleanse the cell membrane and cleanse what? Cleanse the lymphatic system with another a channel of elimination, cleanse the lymph node, all of these things, and then cleanse the liver. Okay, so we have to see how all of this is say connected.
Yeah,
That's
but
why you don't go say, I just want a liver cleanse. It's not very good to do that. It's not very good just to say, I want liver cleanse only. Yeah, it's gonna help you a little bit there. It's not very good to do so. The best, cleanse all the 8 channel ones. People want to cleanse this colon. I just want to cleanse colon. No, you can't just clean colon. Clean the whole system, everything. Cell membrane, kidney, liver, colon, everything. Your lungs, everything out.
At the same time,
At the very same time.
yes, and we established that the life of our flesh is where. So if we clean the blood, what else do we need to clean?
The
So-
lymphatic fluid.
So once the blood is actually clean, it's like cleaning the whole system because it's the blood that is recycling in the system constantly. So it's going in and it's going around in our body all the time. So if the blood is clean, which would include cleaning the lymphatic system, so it's not in isolation. Right. So, and that is why it's possible to look at the blood under the microscope and tell. It gives you a good idea how your body is functioning. You could see water molecules attaching to the outside of the cell. You could tell what is happening, what the level of dehydration is, how much fat is in the system. It's so many things that you could just look on a sample of blood and it tells you how much parasite is moving around, how much undigested fat you have in your body, how much you have sensitivity to starch. You could see all these things just looking at one drop of blood, you know. So we're going to try to see if we could label these without actually looking at them. So this is the plant cell and this is the animal cell. So we could start anywhere. So this is a plant cell and it's synonymous. So inside of the plant cell, it's usually not the structure of the outside that changes, it's the inside that really changes. If you look at this, you can see the change, and this is, so let's look at them and see if we could tell which one is which. So this one would be what? Huh? This one is isotonic. Okay, so what would this one be? Hyper. And this one would be? Okay, see this one has a smiley face? Yeah, and this one is happy here. And this one, the same thing. When you look at the inside of the cell, you could see it shrink along the side. And which one would this be? Which one is it? Hyper. This one is equal. If you look at this one, you see kind of bulging on the outside. Yeah, so that one will be hyper. Alright, so this is materials passing through the cell membrane. We talk about passive and active transport. So we have passive transport, which is simple diffusion, right there, which, and what are some of the materials that can go through easily that we mentioned earlier? So we said oxygen and what? Carbon dioxide And in some cases it's water, yes. And then we have facilitated, which is also passive, doesn't require energy, just runs through. Okay? And the passage of material is aided both by concentration and by a transport protein. But it doesn't require energy still. And this is kind of how water goes through. Okay? Now, active transport require what? Energy. So ATP means energy. So it means that it requires energy. So the force here, if you notice, there's a squeeze and it pushes and it goes in and it goes on either side, whether you're going into or out of the cell membrane, it's going on a concentration gradient. Okay? And this is passive, so simply it doesn't require energy. And we talk about carbon dioxide and water. And we have passive transport, which also, it's just a channel through which it goes through. And these are glucose molecules that will just go through the passage. And these are protein channels, okay? And these channels, it's possible that they could be clogged, okay? So that affects our energy level. And here it tells us that protein is very, very critical for memory function. So these are the different, it's a structural support, so it keeps the cell membrane together. It's for recognition, and this is like enzymes. So for example, enzyme only work, or they only work like a lock and key. So it needs this, it enables recognition. And for communication, so a communication of sensitivity, what goes in, what doesn't go in. So it has to be able to detect what goes into the cell and what doesn't go in. And for transport, okay, so it's different different ways the protein work within the cell membrane. So it channels protein are embedded in the cell membrane and have a pore for material to cross. Carrier protein and chain can change shape. So, so they are very flexible to move material from one side of the cell membrane to the other. Like I was telling you, for this one. So it goes both ways. This one closed or this here closed and it goes in or out, depending on. So it works like, yeah. Here we have facilitated diffusion. And does this require energy? Does it require energy or just need a channel?
Nope.
So does it require energy? So it needs a channel for it to pass through. So the pores open up and it goes through. So it's randomly moved through. So this is facilitated. It's a different way that it occurs. So they bond the molecules and drag them across the cell membrane. And all of this require, there's a lot of work that the cell membrane does in our body. It's more than what we imagine. We take it for granted, but it's all happening right in your body every minute, every hour of the day. These are protein carriers. So it changes the shape, collects them and push them out. This is kind of how sugar is pulled out of the blood, like the liver pulls all of that sugar, more excess sugar or glucose out of the body, stores it in the liver, fatty acid and glycerol. And that's why when you eat so much starch, the liver become what? You get what? Fatty liver, right? Right. So this is active transport. And active transport require energy and move material from low to high concentration. It gains a concentration. And this is like going up a hill, right? So we're like climbing the hill right now. where this one is concerned. Example, so we are pumping sodium ions out and potassium in. So this is against the concentration gradient. So we know about the sodium potassium pump within our body for normal, regular, normal functioning in our body. So these are some of the minerals that are so critical for control of blood pressure. It is just taking in minerals and releasing excess of what we don't need via the kidneys or the skin or whichever organ it is leaving. But the sodium potassium pump is very crucial for the normal functioning of the body. This is kind of how it works. It takes in, drop off, so whatever is needed, when you have excess, it pulls it out and it releases, and this is kind of how it works, the sodium potassium pump, the right amount of sodium potassium. Because if that balance is not there, then we will have elevation of our blood pressure. So people might say, oh, I shouldn't eat salt, but if we don't have enough salt, there's still going to be an imbalance. When I say salt, I mean real salt. And then we have another function of the cell membrane that it's remove extra protein in essence. And this is like one of the biggest things, just looking at blood, different blood samples. You'll find that a lot of people have excess protein in their body. When we have too much protein, the protein
It's 6 o'clock.
And the cell membrane, it's what it does is wraps itself around it and move it out. So it pushes it out of the cell, and the kidney eventually picks it up, and sometimes they form crystals and they mess the kidney up because excess of it can result in damage to our kidneys. So when we eat too much protein, and this is one of our crime, because when we stop eating meat, we feel like we need to eat a pound of peas in one meal in order to make up for the protein that we are not getting from our chicken and our fish and all the other meat that we're eating, because we don't think that nuts has concentrated protein and beans and peas. We think we need to eat a whole lot more to make up for not eating fish or chicken. But when we do that, we are creating, we're causing a lot of damage within our body, because too much protein is more harmful than good in any sense of the way. The body doesn't have a way of storing protein. So you either you just throw a lot more work on your kidney, and this is one way the cell get rid of excess protein that is inside the cell. So you move it out by vesicle, and this is how many hormones are secreted and how nerve communication with one another occur. Okay? So it is just a communication. That's a way of communication. This is just a live image of how the vesicles work.
Question. What about taking the protein digestion? Like you take special enzyme to digest extra protein that are mixing up in the system.
And what would be the purpose of that? Are you going through a healing process where you feel like your body needs extra protein to build and repair cells?
No.
I'm just trying to understand.
Yeah, I'm trying to repeat.
Okay.
Like let's say you are like American, right? They are heavily on protein. A lot of enzyme to rebalance everything out. To start like digesting all of this bad stuff from your system quickly. And there is a doctor, his name is Dr. Gonzalez, and many others do the enzyme therapy. They put you to 150 enzymes a day, sometimes 200, to be able to digest this bad stuff from your system. And some of the parasite and bad stuff, they are form of protein that can be easily digested if you take high dose of enzyme. So, what that has to do with the excess of protein that people are like eating or taking.
Okay, so your question is, how does taking extra enzyme assist the body in digesting more protein?
No, that's a little bit different. In digestion of protein itself, you just need hydrochloric acid enough in your stomach to break it down. We are talking about you already have excess of protein breaking down to amino acid that go in your system, and now you have all that excess of protein that when they find it in your system become toxic to your body. So now you want to digest that protein. Let me give you an example. Example of the long chain of what do you call it?
Polypeptides?
Hmm?
Polypeptides?
Or peptide, or the regular one we call, what do you call it?
Amino acids?
No, the regular one that is that in the wheat, what do you call it? The long protein chain. Gluten, for example. Because your gut is broken, that long protein should not go through like that. When you go through like that, go into your system, they're going to look at it, this is a stranger, should not be here. It creates serious and massive inflammation in your system. So how do you take out that protein? So some of doctors recommend that you take some special enzyme to digest these things because they are already there. You know, like to destroy it. And some of the bacteria also have like a protein form that need to be destroyed, need to be digested out. So I was asking, how does function with the excess of what you was talking about before?
Oh, so we were just saying that, well, it would speed up the rate of removing the extra protein from the body if you take in the enzyme. Like the lysosome is one of those organelles within the cell that also work in the same way, it wraps around it and wraps the protein and then digests it and pushes it out. Okay, so it works in a similar way. So speed up this action.
So it assists that.
Yes.
Excuse me, does probiotic help in the aid of digestion?
Somewhat, yeah, but because probiotics is a flora and fauna, but it's digestion in the lower, like, when you talk about, when people get bloating and stuff like that, it's because the flora, the microorganism in the colon is not very active, they become very dormant, and because of that, when stuff like when the digestive food that leaves the small intestine to the large intestine, when it leaves there and it goes down, absorption is not ready. So the lower intestines or the colon is functioning very slow. So sometimes you have fermentation, it causes bloating. So the whole idea, and it helps in digesting, breakdown of some things like vitamin K down there you might have, digestion continue at that end. But it really assists in absorption, reabsorption, and help to activate things in the colon so it moves along faster. Instead of sticking on, sometimes they just stick on because, mucus and all of that causes stick in the different pockets in the colon. And the probiotics in there will definitely help to speed up the process, of how things pass through the colon. And this is also extracellular fluid, pinocytosis. So here and this is most common form of endocytosis, and one we had earlier was substance leaving, and this is endo, meaning it's coming in. So when we have low protein or whatever, it will pull the protein molecules in so that the cell can function normally. And this is how the process works, taking it in, and this also help, build the cell membrane, because the cell membrane need protein to function properly. Okay, so this is in essence how it functions. And this is a live picture of an example of how it works. And these are receptor molecules that's on the outside here. So some integral protein have receptors on their surface to recognize and take in hormones and cholesterol. Is cholesterol bad? Why is cholesterol not bad? Because cholesterol is labeled as something really bad.
Cholesterol is not bad at all.
Oh.
Why?
Excess amount of cholesterol.
Why do we need cholesterol?
Because cholesterol. Somebody answer it.
I'm not sure.
Pass it on to me.
You see, your cell membrane is 50% cholesterol. Your brain is highly made of cholesterol. All your hormones are made from the raw material of cholesterol. You cannot live without cholesterol. You just cannot.
Excess amount of it is bad.
Now, the cholesterol become a problem when you are becoming acidic. Listen carefully. Let's say in your arteries, you're running acidic blood through the artery. What happens? It's eating up the wall of the arteries. So the body sends cholesterol to go repair things. Start patching things. I'm just putting language we can understand. Start patching stuff. More acidic blood pass, more cholesterol need to come hang up. What did you get finally? Atherosclerosis. Because the cholesterol becomes so built up, they become a problem. The problem is not the cholesterol. The problem is the acidic blood that requires cholesterol to keep coming to do the work. So it's a very important for us to understand that you cannot function without cholesterol. Cholesterol is not the problem. But it's this lifestyle that making you acidic that created the problem. Yes, they talk about bad cholesterol also, so I'm going to let her go for that one.
Thank you.
So why do we need cholesterol medication if cholesterol is so good?
Excess amount of cover for arteries.
We don't need cholesterol
So
medication. No.
what happens when we take the cholesterol medication?
All the different things happen because these are drugs that destroy your system.
No, it's helping the patient. Listen carefully now. You need cholesterol to make hormones, right? Now you're taking something to lower your cholesterol. What are you lowering? You're lowering the manufacture of your hormones. Most of the men taking statin drugs, they end up impotent. You can't function anymore. They start losing the brain. Why? The brain is highly made of cholesterol. If you take a statin drug, you are going to end up extremely bad. So, the patient should not take the statin drug. If that all the only thing you know, you start taking it, now you start changing your life. Because that's helping you for a time. Now you start changing lifestyle, start balancing all things, changing your acidosis, balancing everything, and you slowly come off the statin drug and you repair everything. I don't recommend it, but if the patient don't have no other choice, you're gonna be on that and then transit slowly until you get completely relevant.
Right. So the cholesterol medication will wipe everything out. And then your hormones, as you said, men, testosterone level falls. Once you go on it, it's just like impossible to build that testosterone level up. So it takes a long time after it wipes everything out. So that's where the
I
problem
have a lot. Look at women, you're taking this statin drug, all of that.
is.
Your hormone going down, your bones start going down. And plus the menopause, everything goes like you start, oh my knees, my this, everything start breaking in your body. So why is doing that? It's the statin drug lowering your cholesterol. Without cholesterol you can't make anything. You just cannot.
Women are affected. Men, they'll become impotent eventually.
And lose the brain, both.
However, women, seems like, well, I guess we have a lot more hormones that is affected, so for some reason, it seems like it affects women more.
Yeah,
Than it
women are
affects-
much more affected.
Yes.
The bones are breaking, the
Everything.
knees are gone,
The heart start malfunctioning.
everything. The brain fog is hard,
Mhm.
and now you're in menopause now. So when you go to menopause, you have 30% drop of your collagen. You need collagen to build any new material. So you start aging very fast.
And
Like everything starts going
progesterone
down.
drops. So when the progesterone level go down, it's like women become crazy. Like crazy people.
Talking and laughing. It's like it's hard.
Miserable forever.
You know?
With what you're going to recommend. Because if they don't agree, leave it alone. Just leave it alone.
Yeah, because what I hear is the speaker saying, oh, starting to draw is bad. They will destroy you. When he says that, someone will give up. But you don't give him anything now. The next week they say he's dead. So you kill him. You go into jail.
You never say what they couldn't to stop you. Alright?
I'm just trying to say like how people gonna perceive it. Because if you tell to any man,
Yeah.
any man on earth, you tell him something gonna knock down your manhood, he's gonna quit. He's gonna quickly leave it alone.
Because you must have enough intelligence not to tell the person don't to stop taking the job.
No, you don't tell him, but that's instant you just say how bad is the thing without giving alternative. It can create a lot of damage. Just say that. Like how we approach them to let them know that you don't come off the. You gotta be educated, choose to do the right way, and it starts slowly with your doctor to lower them until you come up.
Yes, and this is also another way the cell memory work by, engulfing it's called phagocytosis, bacteria and other things that try to get into the cell and destroy them and pushes them out of the body. This is also exocytosis is another way cell memory work to transport things across. So, looking at this, we just seen how much things is happening just within one little microscopic thing. You can't even see it with your real eyes, but this is what is keeping us going. This is what is keeping us alive. So it is taking things that's in the cell, pushing it out, and it is also working to it also does the reverse as well by taking things and pushing them into the cell. That is absolutely necessary for the functioning of the cell or the whole body as a whole, because we're made up of billions and billions of cells. And this is what keeps us alive. Your liver is made up of cell, your kidneys are made up of cell, your skin is made up of cell, your colon is made up of cells. So all that we just went through is happening in all the individual cells in your body simultaneously. So if this is what is happening within all of those cells in your body, now how do you believe that this impacts our health if our cells are not healthy? How does it impact our health? Whatever it is, can you help us out?
Cells, that is the basic thing of the guy is sick. You can imagine the rest of the body is going to be sick. It's not going to work properly.
So how do you think it will impact someone who has diabetes?
As you said, it just, for example, this sort of travel with this membrane, so transport can happen to insulin and get into the cells to transport sugar. And so if the cell is sick, and so that person is going to be very sick, diabetes is going to be treated, that person is going to.
So what happens if they're on medication for diabetes, they're taking insulin? Do you think that will change how much go across the cell membrane?
It helps, but at a certain point, the insulin, so if the cell is going to be resistant to insulin, the cell can get worse and worse.
What do you mean get worse and worse?
Well, become insulin resistant.
And what happened in that process?
And they give you more insulin,
And you resist also more.
resist more, and thank God they have technology to allow to have different kind of insulin. That one doesn't work, that one works, that one works. But if you get to a certain point, you're gonna die. You get to a certain point, you see young people die, they die.
Young.
Yeah, I have a 30-year-old who lost one leg, half of another leg, and the rotten leg because of insulin problem that we have, so they die. Slowly this one is gonna die.
So what is the other solution you have for?
Clean the cells.
I have some.
Clean the cells.
Change the medication. That wouldn't be a, I mean,
No, he already changed all of it. He already changed all the kind of things. That we cut off the one leg, we cut half of the next one.
yeah, but you have to work with them where they are.
Actually, the other one, the doctor wanted to cut it off, it's that one. It's a candidate to be
We are suffering from ignorance, though. That's the problem. Because when that thing started, if that man had changed his lifestyle, diet, thinking,
But he has to know
everything.
that first.
Yeah, that's why what people need today is not medication. It's education. We have to medicate
Yeah,
these
but they
people.
could be educated, but they are choosing.
Oh, then if you choose, then we're gonna oppose. Then God will not oppose that.
We don't have a system. We don't have a system for education. We have a system to.
See that? You also laughing at that, right?
Dad, you in?
We don't have a system for that. And actually, the person himself doesn't really care. He does not listen.
Okay.
So in a case like this, right, they don't take the person off the insulin medication. You show them the importance of cleaning their body, cleaning their cells. And that would eventually reverse the diabetes question.
Say it again.
In this sense, if somebody is on diabetic pill, right, or injection or whatever, you do not tell them to get off the insulin. You show them by education where their cells need to be cleaned. All right?
Yeah. Not the cell. You gotta explain to him the whole system. It's not
Oh,
just the
because-
cell.
Okay.
We are talking about the A channel. Cell membrane is one.
Yeah, but remember, I was said that all your organs and everything is made up of cells. So if the cells are covered with grease and whatever you have, their fats and all that, you need to clean the cells so that to reverse the diabetes and eventually the person will be off their medication.
Yes, when you're talking about cell cleanse, where did the cell bathe? All cell, where they bathe?
The blood.
Lamb, you see, we have a blood, but we have more than 3 times. If you have 1 gallon of blood in your body right now, you have more than 3 gallons of lamb fluid. Every cell, you see the way you eat and you pee and you poop, every cell does that. Every cell in your body poop. And yeah, they eliminate into your lymphatic system. And they pee right there. That's why you have to exercise to sweat. That's the reason why God puts the hair on a place you have more lymph node. And now we think God's not smart enough. We shave everything out. You shave everything out, there's no more heat. You see, in armpit and your private part, that part, that's why you have much more of a lymph node to do what? To excrete, to eliminate these toxins from your lymphatic fluid. So when you're talking about cleansing the cell membrane, you cannot have a clean cell membrane if where the cell is bathing is dirty. It's a whole system. Do you understand? You can have a clean cell membrane if your liver is not working very well. Why? It won't manage the fat well. You can have a clean cell membrane if you keep eating acidic food, mucus forming food. It's not going to work. So when she's talking about the health of the cell, you gotta know it's involving everything to make that cell healthy. You eat mucus forming food, you can pray and fast and do whatever you want. You are going to be right. So it's a whole package, the whole package. That's the reason why if the person can't do exercise, what do we do? Stick it in a sauna. To sweat out, you have to sweat. It's a must. There's no way around. There's no medication against that to replace that. Sorry. Are you getting my point right now?
Sure.
So it's a whole package.
Was that your question?
Huh?
He forgot his question.
I will forget.
Mhm.
I thought your question was like somebody is so sick, take that person aside and educate that person and about his
No.
condition and
He's talking about cleansing the cell membrane. When you have the person sick on a medication, I say yes. But the cleansing of the cell membrane must involve everything else. You can never, because that's what I want us to see. You just cannot go, so you know what? I'm going to cleanse cell membrane. You can't do it. Because cell membrane don't walk around by themselves like that, you just go clean them alone. I'm sorry to say that way. You gotta change everything. Diet, sleeping well, exercise, because for example, you go to bed 9 o'clock, what happened? The body itself starts secreting the hormone and all the other stuff that needed to go and start repairing things for you. You know when you're tired, very tired, you go to bed very early, what happens in the morning? You feel good. What happens in the night? In the night, the body is cleaning all of this lactic acid accumulate, all of these things. If you should go to bed now, you don't. You go 1 o'clock in the morning, what happened? No work is done for you.
No.
So now, guess what? You're cleaning cells, right? You know, exercise, you know, eating right, sleeping late, doing all of that. How are you going to function? How is it going to be cleansed? Are you getting my point a little bit? So you can't just clean the cells. So what I'm trying to say is, as she said, I don't disagree with that. The cell is the key. But you can't have the cell cleansed if anything else is not touched. It making sense here? The whole package must come in.
But who gets a chance to do the whole package in this life right now?
You
Really?
try your best, already.
Oh, okay.
That's why you change your diet, right? You exercise than before, right?
Mhm.
You're sleeping better than before, right?
Mhm.
Even your thinking, the way you manage problem. Before we can take up one, so now we can go in prayer with it, right? So all of this is coming and slowly going. If you want to do 100%, there is a whole progress of changing, and country gonna be imposed to you if you want 100% change, because you need pure, clean water. If you have the well water in the country, then you will save a lot from a lot of toxins we getting from the shower room. You know, you want a clean air, then you're gonna be in a country where when these herbs, when they blow their own essence, when you breathe this essence inside, it's healing you. You have a free aromatherapy right there, just for free. Here, what do we breathe? You go in the subway, you breathe all of these things. You go in your car, you breathe more other stuff. And you come, you go and take the shower, you bring all of this gas chamber. You go cooking, you breathe in more. That's how I live. That's the reason why everyone should be constantly taking something to cleanse, to detox. Take some charcoal, clean your colon, clean the H channel. You must be doing it. So if we see it and we think that by God we're going to be fine, it's not going to happen. The grace is the knowledge that you put in action when God gives you power to obey.
I think what we need more is to educate children from a younger age. Like
Exactly.
if you can come out of the city earlier, that you can really get, if you're going to have a family or what, because we don't know how long more we have on the earth, whatever. But I think it would be, we can help, because when you get a certain age, you have so much responsibility. You can't get enough rest. You can't drink enough water. You can't this, you can't that, you whatever. And it's like the only thing I can see is if we can start teaching children this, like the importance of these, learning this, instead of going to get a doctorate, and when you're done, you have all the bills to pay. You can't take care of your health. You end up sick. Then you bring another family into the same process of getting sick. I think what we need to do is to really pray that God can show us the way out, that we can start teaching children from young this message, because I feel like you have such a big responsibility, like to learn this so much that you can really help people, to change from now, Huh?
You asking? Demand the money, tell me if you really want to go to work before you go.
Okay.
Demand the money. Try to see if you really want to go before you get up and go stay.
Because when you see these things,
more than
you
that.
realize how much you need to help people, you know, to get rid of this slavery mentality. Like, I have to take these drugs because I can't drink water at work. I can't do this. We need to somehow pray to God to help us to get out of it, you know. Mhm.
Help us.
I mean, can you help us to understand how cholesterol could clog the cell? Cholesterol, what does it do to affect our cell membrane? How does it affect our cell membrane? We have excess cholesterol in the body. Anybody wanna help one?
And builds up on the cell,
What builds
and
up?
stop towards the cell.
on the
Okay.
cell?
Excess amount of,
Now.
Cholesterol.
That is the same process of acidosis.
So,
The body is to release the cholesterol to protect itself.
yeah,
And then plus the bad cholesterol itself from digesting the trans fat, this bad fat also sticking fat coming in your system. There's both sides. So when you have cell membrane, very good healthy cell membrane, and then you go you fry, well people eating fried stuff. You take canola oil or soy oil, and then you fry carbohydrate, you made a perfect something to really mess up your system. You drink, you eat that food, you digest it, there's a bad fat going in your system. Okay? And that bad fat is sticky. It's not very healthy.
sticks to yourself.
Now,
stick to the walls of the
That's-
arteries, which are cells in itself.
that is one.
What makes
Now
cells?
number two for the same cholesterol, the cell membrane. When the fluid is getting acidic, when your lymphatic fluid is acidic, guess what happens now? The cell needs to protect itself by secreting that. So therefore you have too much cholesterol buildup around the cell, including also the what you call it, mucus. Mucus is not bad for us, same like cholesterol. Mucus is there to protect you all the time. But when you put too much of bad thing and you need more protection, the same mucus that should be protecting you will do what? Will kill you. So you end up building too much mucus in your lungs, right? It will kill you. It clogged up all your
The cell
bronchi.
membrane.
Huh?
The cell membrane.
I know, I'm just giving an example that the same thing there.
The
The-
alveoli.
So the mucus is there to protect us. But when you are exposed to too much toxins, then too much protection, then you have excess of good mucus that become what? Dangerous. Okay? Same thing for cholesterol. Cholesterol is there to help you. But when you require too much help, they become too much problem. So it's two things. So it's two things. The bad fat that you are eating, you need to stop it. Then diminish the acidosis and then bring back the things. So the cell membrane around the cholesterol coming from two sources. The bad fat and then the acidosis.
What about sugar too? Sugar plays an important role in that also.
Yeah, sugar
Excess
increases your
amount of-
acidosis big time.
Excess amount of sugar is built up and
Yeah,
stored as
sugar
fat.
increases your acidosis big time.
So what it does, it stores in the liver when you have
That's right.
stress, and then the liver becomes fatty, the liver don't function properly. You don't break down fat because it's not producing the bile, and all the bile that you need to digest all the fat that you take in. It's just, so the fat float around in the blood. You can literally see that just floating around in the blood. That's how the whole system becomes acid, and then start clogging on the walls of the arteries when the walls of the artery has damaged areas because of acidity. That's what I see. Do we have any more questions with regards to
No.
this? So,
I have a question.
okay, so let's look at where we are with our experiment. So this is,
Completely black now.
yes, so what happened here? What causes this to be black? Anybody could help us out? Kim?
That means that Kim.
What-
Oh, yeah, you said the starch actually turns the whatever
Iodine.
it touches to black. So whatever the starch comes into contact with that solution, it turns black.
So how does what role does the cell membrane play? What happened? What's the name of the process? Diffusion. So diffusion occur, and this is kind of very similar to how
Now,
our
diffuse from where to where. Like which direction? We have the hypo and hyper.
So where does what moves from where to where? This was not tied properly? That
Yeah,
was
so
one
now
thing.
I leak out a little
So
bit.
it leaked out and then causes this to be that.
Yeah.
So it's not like the starch moves through the cell membrane,
Backward.
because the starch cannot go through the cell membrane. And likewise for our bodies, starch doesn't go through the cell membrane in the same way. The iodine is smaller
The
than
cell
that.
membrane doesn't allow it to.
No, it's too big. Remember we said it was too big to pass through the cell membrane? So only the iodine could go in. But one of these wasn't tied properly. So if you notice when I took it out the first time, we could notice that here was getting dark. That's because the starch was running out. We ran out and get into this, but starch is too big. What does starch break down to enter the cell membrane? Glucose. So it has to break down to glucose, and even when it breaks down to glucose, it doesn't freely pass the cell membrane. It needs a protein channel
To
to
transport.
bring it across the cell membrane. So it doesn't go through that easily. So, this is just a simple demonstration of how your cells function within your body. And I hope that this helps you to understand better why it's important to cleanse, clean your cell membrane, and clean all the other channels.
How often?
I would recommend once every 6 months. That would be ideally for us in New York. We live in New York, it's really, really a polluted place. Once every 6 months.
6 months.
Yes!
That's too long.
I mean, if you're really gonna do a real house cleaning, like spring cleaning, once every 6 months is ideal if you're eating right every day and
Well,
doing.
I don't disagree with it, but 6 months is too long. Because you can have a lot of damage during 6 months.
If you're eating, right, to a great percentage.
So what
How
about,
often would you recommend? I recommend once every 6 months.
no, it depends, if it's come to what I understand. Somebody wanna speak? If it depends what I understand is, if you know the cell have problem, I'm gonna have problem, so what do? I prevent it from happening. So every week, I'm taking something that I don't break things that it become problem. Am I making something like make your lifestyle to be a cleansing things to be going on.
I agree with that.
It just depends on how.
Then every 6 months is okay. Are you understanding me? The way people live, if they live like that, you want to do twice a year, it will kill you. The way you live, you wash your diet, you eat more raw, you do more juice, you do much more juicing. For you, 6 months, perfect. But most of the people who are vegan, they will eat a ton of rice, ton of bread, because it's a whole wheat bread, whole wheat. But it's a 7 grain. It's 7.
And I just want to say one thing, that in my studies and research, I was just,
Six
just
bags will
looking,
kill you.
and if you're diabetic, whole wheat has a higher glycemic level than white bread.
Yeah,
So
you
it
know
pushes
why?
up your blood
Because of
sugar.
dioxin.
Yes, so the glycemic level on the whole wheat bread is higher for diabetics. So if you're eating healthy, you're eating whole wheat bread, your glycemic level is.
Go up and you died earlier. In the name of misunderstanding and miseducation.
The cleansing, how long does that take and what is it?
I recommend if I put you on a program once every 6 months is a 30-day cleansing. So that's thorough. After that 30 days, you should eat or if you're consistently cleansing, as Pastor Kuku said, then, you know, the next 6 months is good. Meaning,
how many days,
so,
30 days again, or?
so
Like every week.
I recommend every 6 months. And
For someone who is a health conscious
For a
and
major.
obeying the law of health, I really suggest you add that to it.
And what,
It's a suggestion.
and what,
every 6 months for someone who's obeying the laws of health.
Yes.
and someone who is
Health conscious.
80-20.
Basically, is who? You?
80 raw, 20 cook.
That's just a thing.
Now, for those who are doing raw, I suggest you study a lot about vegetables. Some of the vegetables need to remove them.
Some of the vegetables,
Yeah.
Yes.
what?
Because the way they grow some of them,
Oh,
and if the vegetable is too rich in lectin, you're gonna be very, very aware of that because lectin really creates leaky gut. Even your gut, you can
Okay,
be
so-
What
serious.
vegetables are you talking about?
Like,
Cabbage.
you sure? Or you just say it?
I know.
No, no.
You mean for the green juice?
No, let's listen to this. Is it cabbage? What is wrong with cabbage? How much lectin you have in cabbage?
Huh?
How much lectin you have in cabbage?
I don't know
So
exactly.
can we
but I know.
discuss the
Yeah.
lectin another time?
Yes.
Just close this segment and then we can,
And there we go.
yes, because that's a whole
Lot
nother
of
world.
stuff there.
Exactly.
A lot
And
of
when I tell you to, you'll cook everything, it's a whole nother world of story. So let's just close for now. So